pH! Look, I'm a Wookiee. No, that's not what a Wookiee sounds like. So we're going to talk about pH. We're going to fill in some of your gaps in knowledge on acids and bases and pH. Particularly, we're going to talk about calculations and calculating pH. So Soren Sorensen, really famous guy involved in calculating pH. Here again is the chart of pH from -1 all the way to like 14.5. It can go a little lower, a little higher, but generally 0 to 14 is our typical pH range of non-freaky things. So self-ionization of water. So to understand pH calculations, you have to know that when I told you that water does not conduct electricity because it's not ionic, it was kind of a lie. Kind of. A little bit. Because water, it's considered a non-conductor. There is a slight but measurable conductivity because of self-ionization. So water plus water molecule becomes H3O plus and OH minus very, 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 very small amount of the time. However, the beauty of this is this is something called an equilibrium, which allows us to create an equilibrium constant for water. You don't have to worry about the complications of equilibrium and equilibrium constants yet, but we do need to understand that there are, in pure water at 25 degrees C, we know that the concentration of hydronium ions, H3O plus, is always 1 times 10 to the negative 7th. And the concentration of hydroxide ions at 25 degrees Celsius is 1 times 10 to the negative 7th as well. Now, one of the beautiful things about this is it's always in equilibrium, which means Kw, no matter what at room temperature-ish, 25 degrees Celsius, is a constant. So Kw is always equal to H3O plus and OH minus concentrations multiplied together, and it's always going to be equal to 1 times 10 to the negative 14. But if OH minus, the hydroxide ion concentration, goes up, the hydronium ion concentration will go down in an equivalent and opposite way to maintain Kw equaling 1 times 10 to the negative 14th. And this is the beautiful thing about an equilibrium, is that the equilibrium constant is always the same, even if the other values change. So if you know one, you can always calculate the other. So calculating pH and pOH, so here's the nitty gritty of it. What you actually want to know is that pH is equal to the negative log base 10 times the concentration of hydronium ion. So pOH is the negative log of the concentration of the OH concentration. pH plus pOH is always equal to 14. Concentration of H3O plus times concentration of OH minus is always equal to 1 times 10 to the negative 14. So to find the H3O plus concentration, you can take 10 to the negative pH will give you the hydronium ion concentration, and the hydroxide concentration is 10 to the negative pOH. So with all of these equations, you should be able to convert in between and back and forth between all of these amongst. So pH plus pOH is always equal to 14. So if pOH is 1, pH is 13. If pOH is 9, pH is 5. If pH is 2, pOH is 12. This is the chart that will let you convert between any and all of them. It already has rearranged and done the algebra for you for all of the equations, and will let you do all of those calculations if you just follow the arrows. So if I need to convert from hydrogen ion concentration to pOH, I can take and say that the OH concentration is 1 times 10 to the negative 14th divided by the H plus concentration, which would be what I'm given, which gives me OH, and then go from OH to pOH. That pOH, we follow this arrow, is equal to the negative log of concentration of OH. And that will give us our answer.